Hello, everyone. What I want to do is go over exam 3. So the exams were graded and the final grades are all on Blackboard. So for anyone who has any questions on exam 3, I'm just going to go over this. The scores were pretty good. B, median, and average. I was a little lenient on some of these problems. But and for the whole course, the median was a C plus, and the average was about a C. So not bad. A little lower than I like, but it's fine. Okay, so problem one: you pay off a 20-year, $50,000 loan. Equal payments K at the end of each year. For the first 5 years, interest is 4%. For the last 15 years, interest is 3%. Immediately after receiving the loan payments, loan company deposits payments into an account earning an interest rate I. Find I. The accumulated value after 20 years is 120,000. Right, so let's draw a time diagram. And so the first thing is to figure out what the payments are. We have everything we need to figure out what the payments are. We know it's 20-year loan, $50,000 loan, excuse me. Payments at the end of each year, and we know what the interest rates are. Right? So yeah, as always, draw the time diagram. Second. Okay, so for the first 5 years, I is 4%. And for the next 15 years, interest is 3%. Okay? So as usual, we break up the loan into two loans. Break up the annuity rather to annuities. So the first, first of all, the loan amount is 50,000, so that's the present value. So the first 5 present value, the first 5 payments is K, A 5.04. Then for the next 15, it's K a 15.03. But as always, that gives me the present value at t equals 5. So we have to discount it by 5 years at 4%. 1.04 minus 5. Dump this into a calculator or your formula, you get 14.26393K. So 50,000 is 14.26393K. So K is 3503, roughly 34 cents. All right, so now the accumulated value in this account, this new account after 20 years is 120,000, where for this new account, the loan company is depositing these payments into this new account. Okay. So you know the payments are 3503 and roughly 34 cents. Accumulated value is 120,000. So 120,000 is 3503, 34,413. 20 payments at this unknown interest rate I. So as usual, we just plop this into the calculator. Yeah, so I had at least one person kind of write out the equations and say, I have no idea how to do this. I've done this probably over a dozen times in various lecture videos, so really no excuse not to be able to use the calculator at this point. So clear TVM. 120,000, let's make it negative, future value. 3505 34413 is the payment. 20 and compute interest rate, and you get 5.33% about. $5.32738%, or 0.053 2. It's a lot in there, but pretty straightforward. Okay, so next problem, you got a 40-year, $100,000 loan with a common interest rate of 4%. You make payments of K for the first 20 years and then K minus 250 for the next 20 years. Find K, find outstanding balance after 20 and 30 years, and fill out the amortization table. Okay, so draw a time diagram, same kind of reasoning as before. So, yeah, payments of K for the first 20 years, K minus 250 for the next 20 years. Okay, so it's a $100,000 loan. 100,000 is the present value of these payments. So first 20 KA 20 we're given, again, it's 4%, 0.04. For the next 20 years, payment is K minus 250, also a 20.04. But again, that gives me the present value of these the last 20 payments at T equals 20, so I have to discount this by 20 years at 4%. It's common interest rate of 4%. So I'm trying to squeeze this in here. I think that's pretty legible. It's minus 20 here. See? Okay, and you do this and simplify, you're gonna get 19,79278 K minus 15 1550612. And so K, solve for K here. 2 here. So K is 5130689 All right, so let's do the table first. So we have the payments round to nearest cent to make life manageable here. I think everyone basically got this right. I don't remember off the top of my head, but it's right. All right, so yeah, so let's save this 5130.69, store it in the one spot, whatever spot. All right, so we have $100,000, 4% interest for this loan. So interest is 4,000. So take your payment, subtract the interest, take this negative plus recall 1. So 113069. Take minus that plus $100,000, 98. I'll save this in the 2 spot. Make this much quicker. Do that. Okay, so this times 0.04. That's 3, 9. You owe 4% interest on this new outstanding balance. So it's 3,954.77. Okay. Minus plus your payment. So you have left over 1175.92. Where's your principal? Okay, so make this minus plus your prior outstanding balance. Save this in the 2 spot. So 97,693.39. So I would say for other courses, even this will make this a lot easier and quicker if you are good with your calculator. If you have to do this on an accounting exam, create a short amortization table. I would imagine that's something particularly intermediate accounting you should be able to do. Anyway, so yeah, one more. 4% of this outstanding balance is 3,907.74. Okay, minus plus your payment. So principal repaid is 1,222.95 minus added to prior outstanding balance. So your new outstanding balance 96,470. That. $0.44. Okay. All right, so let's finish this up. Let's find the outstanding balance after 20 years. So you do not have a constant payment and constant interest rate throughout this entire loan. The payments change from 5130.69 to 500 less. T equals 20 to T equals 21. First 20 years, it's $5,130.69, and then the next 20 years, it's 500 less. So you cannot use the formula when you have constant payment and constant interest. You just can't use that formula. But you do have constant payment and constant interest for the first 20 years, so we can use the other formula. 100,000 is the loan amount times 1.04 the interest rate to the 20th. That's the loan value after 20 years minus the time value of your payments. 51306,897 S20.04. Remember, it's this formula is basically, if you don't remember the formula, you don't really need it. You don't really need to remember the formula. It's a loan, the time value of the loan minus the time value of your loan payments. And in general, remember that always is true, regardless of any situation, really. Anyway, so this is going to be 66,033,14348. So we do a loan reset. So if I want the outstanding balance after I'll write it in full. The outstanding balance after 30 years, we're going to look 10 years into our new loan. So for this kind of new loan, think of it as new loan, we do have constant payment and constant interest. Constant payment is this K here minus 250. I think I said 500 before. It's minus 250. So use the formula It's a little easier to use the constant payment, constant interest formula. 5,130,6,897 minus 250. So it's 10 years into this new 20-year loan. 4%. So it's going to be 3,9,586.77. Okay, so those are our two outstanding balances. Okay, fairly straightforward refinancing problem. They take out a loan, 40-year, 375,000 constant payments, 9% nominal monthly interest. 30 years, you refinance this mortgage with a 10-year mortgage with a interest rate of 6% nominal semi-annual. Forgot the percent sign, but you also pay a 5% penalty of your outstanding balance at this time. Find out what these the new payments are, the new monthly payments. Okay. Yeah, so let's do it. And I was a little surprised. I would think going from 9% to 6% would make the payments a lot less. Actually, I know there's a 5% penalty, but still, with that penalty, I still assumed it would be smaller than the answer you get. So if you learn anything from this exam, always actually check if it's useful to refinance. Just because you have a lower interest rate, it might not be worth your while to go through the hoops to actually refinance. I mean, this is probably in this situation still worth it, but it might not be in other situations. All right, so the original loan, let's say the payments are K, so $375,000 loan. K, so it's 40 years, so you have 40 times 12, 480 months. 9.09 over 12 is the actual monthly interest rate, so that's 0.0075. And again, 0.09 over 12. J here is a monthly interest rate, the actual monthly interest rate. I better hurry up because this is getting a little low. I still got 20%, right? Okay, anyway. All right, so solve for K, dump into your calculator. We've done a dozen times already. 2,892,605,61. Okay, so now let's find the outstanding balance after 30 years. 30 times 12 is 360. So I do have a constant interest rate, constant payment throughout this loan, so I could use that slightly quicker formula. So it's the payment times A, N minus T. T is 360, N is 480. N is the total loan time. T is time we're looking at. This interest rate per month of 0.0075. And this comes to be 228,347,1828. And it's always a little depressing to look at outstanding balances because, well, it's a 40-year loan, and after 30 years, you've only chipped away. You haven't even, gotten to. It's not too bad. 375,000. You're at 228,000 after 30 years. But you're still nowhere near halfway paid off with the loan, even though you're 3/4 of the way through the entire loan. It is what it is. Okay, so with the penalty, with a 5% penalty. So it's 11,417, 35491, 35914 rather. Okay, so the total that you owe is 228,347,1828. Of course, you could have just taken this right here times 1.05. Sure. That's 11,417,359,14. So yeah, it's 35914 here. Let's try and make that neater. It's a little bigger, so write a little better. All right, so this is going to equal let's K1, K2 doesn't matter I'll still use K. So you still have 10 years left. 10 times 12 is 120. We're given that the interest rate for this refinance mortgage is 6% nominal, 12 months. So the actual monthly interest rate divided by 12, 0.06 over 12 is 0.005. Six over 12. All right, so solve this here again for K. And we get 2,661,88. Actually, I didn't do it without the penalty. It's not a huge penalty relative to the how much you owe, so I don't think it'd make a big difference. But anyway. All right, so number 4. I still had quite a few people thinking that constant principal means constant interest. It doesn't. If you ever do anything business related with loans and mortgages, if you hate this course, fine. But just understand that constant payment is not the same thing as constant principal. As your principal gets smaller and smaller and smaller, you keep owing less and less and less in interest. And because the interest keeps decreasing, that means your total payments keep getting smaller and smaller and smaller. Again, just cookie cutter plug and chug formula to figure out what these payments are is loan amount over loan time plus your interest rate, 0.03, 3%, loan amount minus loan amount over the number of years, time times T. All right, you can simplify this. So K1,000 plus 1,500, K2,000 plus 1,470. So I didn't really stress this, but this formula literally gives you constant principal that you're paying off plus your updated interest rate. Not your updated interest rate, the updated amount of interest you pay off each period. Okay, 3,000 plus 14. I'm just plugging in T equals 0, 1, 2, 0, 1, 2 here. Keep going, plug in T equals 49 to get K, 50,000 plus 30. So it decreases by $30 each year for 50 years. For the second part, and the first part is just 1,000. The accumulated value, and the interest rate for these payments for this reinvestment account is 4%. The accumulated value is 1,000. It's constant payments. That's 50.04 plus 30, decreasing annuity, 50.04. And this here, remember, is 30 times, if I can squeeze this in, n, 1 plus your interest rate to the n, minus s n, your interest rate. So move that over a bit. .04 all over your interest rate 0.04. All right, so you get 152,667.08 plus 152,000.31. So your total accumulated value is 304,667.39. All right. All right, so now we have constant payments. So some people use the formula for when you pay off your loan, where each payment is a percentage of your interest. Doesn't make sense because we're just making constant payments here. All right, so let's first figure out what the payments are. Interest is 3%. Loan amount is 100,000. 40 years. It's K. Loan payments. K 40.03. So we get K is 4,326,2377. All right, so constant payments, constant principal. So the formula is 4,3. It's a payment. You could also use the other formula. It's not really any harder. So it's n minus t. N is 40.03. So what we're doing is we're setting this to be 50,000. We're setting this to be 50,000. We're finding when the outstanding balance first falls below 50,000. So why not use the calculator? It's a little quicker. We have it for this reason. Okay. So this is my n. So dump this into the calculator. 50,000 is the present value. Sorry, clear TVM. This is the present value. 4,326,23,779. Make this negative. This is payment. 3 interest. Compute n. So this is my n here. So we get 40 minus t is 14. 40, t is 25. So your answer is 26. And you can check it if you want. The outstanding balance after 25 years and all prior years is below 50,000. Finally, when you hit T equals 26, dump it in here. Sorry, your outstanding balance is larger than 50,000 for T equals 25 and below. Let's just plug it in for T equals 25. So normally I don't recommend, I recommend doing clear TVM, but in this case it does work to just change N. Let's do 25N, compute present value. Okay, maybe it doesn't work. Sorry, yeah. Yeah, sorry. So 40, it should be 40 minus 25 is 15, so it should have been 15 for N. So I'll just re-enter stuff in. 4326.23779. Payment 3. Interest, plug in 25, 15, N. Okay, so we just get above 50,000. Let's plug in T equals 26. That would be 14 for N. And we get just below 50,000. Keep going. T gets larger and larger and larger. We'll still be below 50,000. All right. Last but not least, what should be a fairly easy MakeHam's formula problem plus a little bit of other stuff. So Don makes a one-time investment. He purchases 30-year bonds, semi-annual coupons, face value of 800, semi-annual coupon rate of R2, and semi-annual yield rate. All these are supposed to be nominal, 6%. Immediately after receiving his coupons, he deposits them into an account earning 3% semi-annual nominal rate. If the accumulated value of everything is 2,300, at the end of 30 years, then find R2 and find the bond price. Okay, so yeah, easy thing to do, and I think most people did this, or at least people who did it correctly did this. Basically use accumulated value plus face value equals 2,300 to find the coupon rate. So 2,300 is going to be the accumulated value of the deposits plus the face value. Well, let's say, so I guess I could do this. 800R. R is the actual 6-month coupon interest rate. This is how much each deposit is. It's F times R. Got 60 of them, 30-year loans, semi-annual coupons. So this interest, this account earns 3% semi-annual. So actual 6-month interest rate for this account is 0.03 over 2, 0.015. And it's the $800 face value that you get at the very end. So you're going to get one second. All right, so let me do this because I didn't quite yeah. Okay, so 2,300. Sorry about this. This is gonna be 1,500. Let's divide by 800. $1.875, or we could have kept the 800, doesn't matter. This is going to be RS 60.015. Let's get that. 60 N 1.5 interest, 1 payment, compute future value. Yeah, I don't think I did declare TVM. I'll just do that. All right, so 60N, 1.5 interest, 1 payment. That was an absurd accumulated value. That makes a lot more sense. All right, so $96.21456. R is 1.875. So take this one over times 1.875. And we get R is 0.01949. So multiply by 2 to get your semi-annual nominal interest rate of 0.03896. Okay, so yeah, now we have everything we need for the bond price. So you could either use Maycam's formula or use the calculator. I don't know which one's exactly easier, but I guess less you have to memorize for exam FM. So maybe Maycam's formula is not the most useful, but whatever. So the K in Maycam's formula is face value 1 over 1 plus your actual interest rate, 6%, or actual yield rate, 6% nominal, so divide by 2, 3%, 60, 135,78647. 800 times 1.03 to the 60 minus. Store this in the one spot. And remember the price is K plus R, which we figured out to be 0.01909 over my yield rate 0.03. So R is quite a bit smaller than the yield rate, so we're definitely buying this bond at a discount. Discount is going to be quite a bit, as we'll see in a second. Okay, so this is K. So let's do 0.01949 over 0.03 times 800 minus K plus K, 567.30. Yeah, quite a bit discount that the bond is bought at. I think $237 about. But anyway, all right. Any questions on exam 3? Just send me an email. Any questions of the grading, whatever. Hope you learned a lot in this course. Yeah, if you ever want to refresh this stuff for other courses, other business courses, stuff you might do it with an MBA, whatever, always go to my go to the YouTube channel. I always post comments, trying to answer the questions there. All right, well, maybe I'll see some of you in the fall. So long, take care, enjoy the rest of your summer.